How big is the gap between app functionality and browser functionality? Is that narrowing?
It is, definitely. So if you look at some of the new capabilities that are coming, specifically stuff like Service Worker, which allows you to now take the web application that used to live in a tab, but then it would go away once you navigate away. Now it allows you to put it onto your desktop such that it's offline and you can launch it from the home screen of your mobile device. You get the offline experience, you get the push notifications. So those gaps are being filled in, and that's a big change for the web.
Are the primary differences now largely in feel? Do you know what I'm talking about? Where it's just how things respond? Is that being addressed as well?
Yes, absolutely. So performance is a big thing, right? So we want to deliver 60 frames per second and all the same kind of smooth experiences, animations, and all the rest. And that exists on the web platform. So we're definitely building better APIs for doing that, better monitoring APIs for you to detect when things have gone wrong. But ultimately, you have access to all the web tools that you use today to build your web experiences, so you can bring that to the mobile environment as well, to your kind of app-like experience, if you will.
Are there any particularly good examples of app-like functionality out there? I mean, who's doing the best work?
So it depends on what you mean by app, right? Because different applications require different things from the app-like experience. So for example, a lot of e-commerce and social-oriented applications want the apps because they have access to certain features like push notifications. So if I have a sale, I would like to push that to the users to re-engage them. And on the web, you couldn't do that because once you close the tab, you've lost the user, or you've lost the context. And now with things like Service Worker, you can upgrade your tab to kind of live in the background, and you can push a notification to it, at which point you'll get that native looking, not looking, it is the native notification that says, hey, this, like eBay is having a sale, or Facebook recently started using Service Worker to push notifications about chat messages and other things. So for them, that was kind of the key proposition. For others, it may be the fact that you can live on the home screen, or access to the camera, or something else. So it's some combination of all of those things.
What do you see happening with web browsers over the next couple of years?
More and more lower level APIs. So if you look at Service Worker, there's kind of an entire orbit of other APIs around it that are being enabled, the streams, the promises, better JavaScript functionality, and all the rest. And all of those are low-level building blocks. We're not giving you like very high-level prescriptive things. Instead, we're enabling these low-level blocks that then allow you to build well-performing, offline-capable experiences, and you can kind of implement your own hooks for how it should respond when the user transitions from offline to online. Like, would you like to do a background fetch and sync your data and all the rest? So more low-level APIs. I think that's the trend you're going to see.
So it's just getting deeper into the system at this point.
Right, and affording the developers more flexibility to build up their own frameworks, right? So let me give you an example. Lots and lots of developers have been asking for lazy loading of like images and other things. And while we agree that that's an important thing, we can't agree on like a spec level, at a standards level, how that should behave, because there's so many different implementations of it. And one implementation that may be right in one context is not what the other implementation wants. So exposing that at a very high level becomes very complicated, because then it's a large and growing collection of settings, and we can't ever make everybody happy. So what we can do, though, is we can give you the low-level tools to implement those and let developers experiment with that. And then maybe a year or 2 years down the road, we'll find that everybody's implementing the same pattern. It's become kind of the new de facto standard. And we can adopt it, and we can actually make it standard such that you don't have to write that code. But it's allowing the developers to kind of experiment first, and then we just sit back and observe and react to that.
So that's the short term. How about the longer term? I know it gets fuzzier out there, but 5+ years. What would a browser look like in 5 years?
Well, I hope you wouldn't even think of it as a browser, right? So you can already start to see this today with the offline applications that you take. You have the benefit of the web, which is that ephemeral, I give you a link, you click on the link, it's immediately in front of you, you're interacting with the page or with the app. And we would like to preserve that. We don't want you to go through now go to the App Store, now search for this, and accept the permissions, right? And then we would like to move that and upgrade it to live on your home screen. and give it all the flexibility that you need to interact with the hardware and other things. So I think that's where we're heading, and ultimately for the user, I don't think they care like how the stuff is implemented. Even today, when you get that app on your home screen, it's indistinguishable from any other app. You have no idea what's running under the hood. To us as developers, it's really exciting because it's web technology, right? We didn't have to write a Java app or something else.
But for the end user, it works, and that's
right.
all that
And
really
for them, it doesn't matter, right? And it shouldn't matter.
Right. Shifting gears a little bit, you wrote a post a few months back where you took issue with browser progress bars. Are those bars actually lying to us? Is that what's happening there?
Well, I claim that they are. So the issue is, so we're specifically talking about the initial loading sequence, like when you type in a URL and you hit enter and something starts to happen. We show, or when I say we, I say like all the different browsers actually have slightly different representation, and they account for different things. Some browsers look at the resources they download. Some are just showing a progress bar because not showing a progress bar is a bad pattern.
Right.
It's actually not tied to anything, or literally anything that's going on inside the system. So they're giving you a perception of the user, the user agent is doing work, which is important to communicate to the user, but it's not actually tied to anything. So from that perspective, absolutely, it's lying. The question is, like, can we do a better job? And that turns out to be very complicated, because how do you, like, if you want to estimate from 0 to 100, what is 100? First of all, is it like the first time we painted something on the screen? Is it something that the application has done? And when you talk to developers, they want to be able to set that 100%, because for, say, Amazon or some e-commerce site, 100% may be I displayed the product profile or the photo, and I have the description. For a news article, maybe I got the headline. I don't care about the leading image or other things, or whatever it may be, right? So we don't have those APIs. And even the implementations that do try harder, that are not just like a spinning thing, they can't reliably estimate. Like up front, we as a browser don't know how much we need to download. So as we process more and more of HTML, we say, okay, well, we need more images.
Right.
So it's kind of like, imagine you have a progress bar that gets to 80% and then it jumps back to 20% because we just discovered that we need. But that's what happens.
Yeah, right. Can you imagine that?
So that's like when you talk to the UX people working on this problem, they're all kind of throw up their hands and say, like,
yeah,
I'm not sure. So this is why some of the browsers have basically given up on the progress bar and they just show the spinner, which is like, we're doing work. We acknowledge that we're doing work, so the user is not questioning whether, like, did I actually hit the go button, if you will. But we need to do better.
And that leads into all kinds of other things, too, because when you're working at the system level, the spinner usually suggests that something is kind of amiss, right? It's not that something is loading, it's that it's sort of chewing on it.
Right. So I'm not convinced that this is perhaps the best proposal, but I think it's an improvement on what's currently there, which is we can't really determine what is the exact best point to stop the progress bar, but it seems like a reasonable point is when we've painted something to the screen and we know that we can now start responding to user input. So there may be other things loading, maybe it's images, maybe it's something else. But as a user, because I do this all the time, I know the page is loading, but if I can already interact with the page, I'm doing that, right? Like I'm scrolling through the article. So at that point, it seems like things have finished, right? And similarly, the other problem with the progress bar is it only applies at the beginning. But what about the other parts of the page lifecycle where, like, I click a button, something triggers, the browser is busy, and now I can't interact with it because it's literally blocked the UI. It seems like the spinner should come back and start spinning, right? And it's just to indicate that the browser's doing something.
Right.
The fact that you can't scroll is, like, that's expected.
It's a big deal. Yeah.
So I would like the progress bar to get detached from the initial loading sequence and be representative of, can the user interact with this page?
That seems reasonable.
That's what I thought too. I'm yet to convince the rest of
Hey, you won me over. Not that I can do anything about it, but you won me over. You've also been writing and talking about HTTP2 for a while now. Why do you feel that's important?
Well, it's a big upgrade to the HTTP protocol. It addresses a lot of the problems, or not problems, limitations in the original design of the HTTP protocol. And to be clear, HTTP1 has been incredibly successful, right? Like everything we've built is built on HTTP1. But in the process, we've built up a lot of what we call best practices, but really they're kind of hacks and workarounds to work around the limitations of the protocol. So things like concatenating files and using domain sharding and all the rest. And now that we have more experience with those tools and techniques, we've realized that they have a lot of drawbacks as well. So we can't do as good of a job on caching. We don't get the same performance benefits out of TCP because we kind of kill congestion control. And there's a lot of kind of subtle and small ways in which we hurt ourselves. And frankly, it just makes developing applications harder, unnecessarily so. So with HTTP2, all that is effectively addressed. It goes away so we can stop doing a lot of these things that we've been evangelizing everybody to do because they had to, right? Like it's a workaround around these limitations. So that's one. The second one is it just enables better latency in a lot of applications. So we can make better utilization of the connection, and we can do better prioritization. We can actually now intelligently prioritize resources. With HTTP1, every resource that we send is effectively equivalent in priority because the browser or the server knows nothing, right? It just gets a request. With HTTP2, we can actually decorate those requests with some metadata that says the image is less important than the JavaScript, and this other image should be loaded if you can, or should be served after that first one because it's slower in the page.
Yeah.
So the server can become much smarter in how it delivers the bytes, the order in which it delivers the bytes, such that the user can have better experience. And then there's a whole like a suite of other features like header compression. So cookies are a thing. We've put a lot of stuff into headers. Those are always transferred uncompressed. Turns out that adds up a lot of bytes.
Sure.
With HTTP2, that's compressed. We have things like HTTP2 push, where the server can push resources before the client asks. So there's a lot of kind of small and subtle things that make both the development experience easier and the performance better.
Interesting. Last question for you. What people or projects are you following these days?
Well, I've been spending a lot of time in the W3C Web Performance Working Group. So most of my time is actually spent there interacting with the various folks at Mozilla, Firefox, and Edge team, of course Chrome, and Safari. So we're talking about what are the new standards, APIs, that we need to enable developers to do better performance monitoring. So for example, a recent spec that we worked on is frame timing, which allows you to detect when the application is missing frames. So instead of rendering at 60 frames per second, when are the applications missing that deadline? Like, why are they taking longer? And that's useful because today you can detect that when you're running in the local environment. So you bring up your developer tools and you kind of run it on your machine and everything looks fine. Everything's smooth. But then you ship it and then you get a bunch of people coming back to you and saying, like, on my device for some reason, it's all anecdotal evidence. There's no way to gather that data out in the field. So that's what frame timing is aiming to address. It's kind of a fairly simple API, but it allows you to detect these cases and then segment them and say, well, for some reason on this particular device, I'm getting consistently bad frame rate. Why could that be? Right? So that's one example. There's many others.
Great. Well, thanks for being with us.
Thank you.